So, Web3 identity, ENS. I had too much caffeine, so my apologies in advance if I go a little too fast, but I'm sure it'll be okay. Raise your hand here if you have an ENS name. Awesome. That's what we like to see. Hopefully we can get that to like near 100% sometime soon, but you know, we'll get there. So, quick agenda in no particular order of what to expect, because most talks have an agenda. It doesn't really matter. What I'm going to cover, what ENS is, top-level domains, Web3 identity, developers, our new documentation, and obviously some cool stuff about the ENS cards. We're not printing them here, I'm sorry, but you know, that's life. So, what's ENS? Super simple. ENS is a decentralized, permissionless naming protocol that lives on Ethereum and scales to the entire internet. And what that essentially means is that I am 0x225F13712134C35, otherwise known as Luc.eth, which, in my opinion, is a whole lot neater and nicely fits on a card. So, where traditional DNS would help us convert google.com to an IP address, ENS allows us to take human-readable names and turn them into machine-readable identifiers, such as crypto addresses, Bitcoin addresses, and much more. Anywhere you can write an ENS address, or an address, a crypto address, or anything of the sorts, you should be able to write an ENS. So in this case, this is an Etherscan example. Let's be real, who wants to see this? And everyone wants to see a name. I went too far away from the mic, didn't I? Here's some more examples in your favorite application, your favorite wallet, your favorite dApp. You just type in the name, and then it resolves to some address, and then you can send some funds, you can interact, or you can chat with your friends. Same story in the top right of almost every dApp you've ever used. ENS is the primary way of doing identity in every Web3 application. We are trustless, we're decentralized, and we're on Ethereum mainnet, as well as on a ton of other applications and a ton of other subdomain systems and gateways and much more. This is a snapshot of the ENS manager, ens.app or app.ens.domains. So why? Why care? I care because ENS is fun, it's cool, it's portable, it's extensible, it's multi-chain, it's a public good, it's decentralized, and it improves crypto UX. And it's just a super cool public good. I mean, what more do you want? So ENS aims to extend DNS. And with that, we aim to extend .com, .xyz, and much, much more. So if you have a .io, a .xyz, a .finance, a .cash, or anything of the sorts, it'll work within ENS. And any of the other 2,000 some odd DNSSEC top-level domains that for some reason I happen to know most of because I've spent too much time in this space. So how? How does ENS work? Super simple. ENS uses a resolution process, and that's all we are. We are just how to look something up, and you're in charge of the rest. TLDR, smart contract go burr. The way that works is super simple. I'm going to give an example. Don't get too scared. I'm not going to go super in-depth. Just kidding, I am. And we'll get there, but I'll spare you most of the details. So the way it works is super simple. I'm Luc.eth. Here's how we see it in an application. And every name has a resolver. In this case, the resolver is a smart contract that's responsible for my name. So when I look up Luc.eth, I get some information from this smart contract that we call the resolver, and it tells you everything you need to know about the name. The way that works is super simple. There's a smart contract on Ethereum mainnet called the registry. Anytime we do a lookup, we say, hey, registry, who's Luc.eth? And the registry will say, oh, I know .eth. It's done by that smart contract. And then it goes to another smart contract. So in the same way that with DNS, we have a hierarchy of DNS servers, we have a DNSSEC chain of trust, we have an SSL chain of trust and certificates in that way, we have Ethereum smart contracts referencing each other and keeping links to one another. So we've got the ETH registry. Amazing. There are also .com one, there's an XYZ one, and there's custom ones for some of the TLDs. Most of them use the DNS registry one, but I'm going to be focusing on ETH specifically. So the .eth registry has another table that it keeps track of all of the .eth names, in this case, Luc, Greg, and Makoto, and a ton more, as well as the contract responsible for each. And in my case, that's the public resolver, which is this lovely contract. And here comes the cool part. That contract right there, you have the ability to change, because if you own Luc.eth, you control what contract is in charge of resolution. And what this means is that you can write your magic in a smart contract and say, I want subdomains, I want profile picture depending on the day of the week, I want a funny username, I want whatever, and it will magically work. So there's this lovely long EIP 137 that introduced ENS. It defines how a resolver works. It doesn't really matter. The long story short is there's ADDR, name, ABI, pub key, and like 10 more. And the way it works is super simple. You write your contract, you add an ADDR function. Anytime somebody does a name lookup using your contract, the name gets inputted as a variable. And in this case, I was the stubborn developer and I hard-coded in my own address because all your money should go to me. I'm kidding. I'm kidding. Sweet. So here's our lovely function, and it returns 0x225F13712134, yeah, whatever. There's also the text function that allows you to return any text record. So if you're interested in someone's avatar, someone's header, someone's banner, someone's Twitter, I don't know, anything else, it can return it as well. This can obviously be way better and way cooler than hard-coded. Right now, this is a call lookup, and it just returns some hard-coded data, but you could load it from an NFT collection, you could load it from a governance scheme, you could load it from participation bills, you can do all sorts of cool stuff and load it from places. This could be whatever you can imagine. Whew. Okay. We did the most parts. Just kidding. We're going to keep going. Thank you for not leaving. What about subnames? So, are you ready? Take a deep breath. Here we go. Super simple. Here's Luc.eth again. Hello.luc.eth in this case. We go out to the ENS registry. Hey, where's hello.luc.eth? Ooh, I know this ETH registry thing that has this resolver thing that has this magic. Amazing. We do our lookup. Our magical code runs. It looks up hello.luc.eth and it says, I would like the avatar and the address, please. Our code does some magic. GG, easy. Next. That was it. Now you know how to build a subdomain registrar, how to give out subnames, how to set records, how to do dynamic things, and much, much more. So, super simple. You bring the resolver, we bring the resolution. And that's it. We're an open protocol, and anybody can build one. Very nice. So, you thought that was over? No. There's way more cool stuff. Text records. Text records lets us store anything you can imagine. No longer are we just storing a Bitcoin address, a Litecoin address, a Dogecoin address, and a bunch of ETH addresses, Optimism addresses, Arbitrum addresses, much, much more, but we can store any arbitrary text value. This could be a verifiable credential. This could be proof that you're over 21. This could be your profile picture. This could be, you name it, your pronouns. You put them there. It's that one, right there, the avatar one. Remember that? Sweet! There's a ton of them that we standardized, but you could, technically speaking, use whatever you want. And so long as apps want to load the information and care, they can do so. Obviously, we recommend you write a standard so that everybody can build tooling and everybody can enjoy, but you're more than welcome to make up your own records as you go. A couple examples of some cool records are the display record, in case your name is multiple syllables long or something along those lines, and you'd like custom capitalization. The avatar record to set your avatar. This can be an IPFS hash, a swarm hash, an Arweave hash, you name it, anything of the sorts, or just a link to your Twitter profile picture. A description, keywords, email, you name it, you can put it in an ENS name. Sweet. Another cool one is, for example, the DM3 profile. You can store info about where people can reach out to you, where people can encrypt messages with, and much more. The header, so you can store a banner image. The time zone, because everybody should be in UTC. Come on, guys, what is this? No, I'm joking. But the time zone, so you can store your time zone. Whatever other thing you can imagine, a CK proof for age or anything of the sorts. A color scheme, but light mode should be the only option, but whatever, some people disagree. Com.Twitter, your Twitter username. Com.GitHub, your GitHub username. Telegram, basically whatever you want. Your app.hello. Got it? Cool? Sweet. So, where can I get one? Where can I use them? Identity. ENS on the ENS app will show all your records nicely, as well as on any other app you can imagine. So here's some of my beautiful records. Here's a screenshot of snapshots. So let's say you're dealing with governance. Nobody wants to see 0x225F13712 blah, 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 voting yes or no. Everyone wants to see names because names are nice and names are human readable and names give us identity. Immutable records. Uniswap is phenomenal, and they use subnames to be able to keep track of where deployments are on certain chains. Uniswap uses ENS names for copyright. Chainlink uses subdomains to be able to keep track of data sources. So if you want to get the USDC ETH price on mainnet, you can just look up the Chainlink name. Decentralized protocols such as Farcaster, letting you set the profile picture and an avatar and a name. Web3 messaging like Coinbase with XMTP, as well as many others. And just letting users enter names. Any text box, a user can enter an address, a user should be able to enter a name. Because it's so much easier to claim a POAP to Luc.eth than it is to claim a POAP to 0x. Okay, I'll stop. I'm sorry. Oh, what did I do? All right. It's really that simple. So, you want one. I get it. If you want a .eth, second layer, Luc.eth, Anthony.eth, etc., you can go to ens.app and it'll be $5 a year worth of ETH plus some gas fees. We understand this might be high, so there's many other options. Uniswap is one of these. They issue subnames using the Uniswap wallet. Coinbase is one of these. If you want the CB.ID, they use the Coinbase wallet. Anybody that uses the Coinbase wallet completely for free can enter in their information, request a name, and get a subname from Coinbase. And this uses that same resolver logic I showed you before, and it doesn't require anything else. Argent with Argent.xyz, Lens with Lens.xyz. GoDaddy recently added a tab where any Web2 domain, your .cash, your .finance, your .fi, your .nl, your .co.uk, you name it, you go to the Web3 tab, you enable it, you type in your address, and it magically works completely for free, instantaneously. Or any other DNS provider. The steps there are one extra step, you enable DNSSEC, and you set a text record. Easy. Want to build your own naming system? Do it. Implement ENS and work everywhere. Not just in Uniswap, not just in a wallet, but in any Web3 application that supports ENS. We're an open protocol, and anybody can build with it. So, let's build. If you're building on ENS, super simple. We built a design system because I suck at making things look good. So if you scan the QR code, you can use pre-built components. You don't have to worry about anything. It'll look nice. It'll work. It'll be great. I'll give you half a second to scan that. Don't worry, there'll be more. ENS.js, a library that lets you fetch any kind of information you can imagine when a name expires, when it enters grace period, and anything else. Oh, sorry. Here you go. Don't worry, they'll be at the end as well. Fresh documentation. We just revamped our entire documentation. So anybody can go to docs.ens.domains or scan the lovely QR code and view our new docs that have dark mode. Ooh, I hear people like that. I don't know, I'm a light mode user. New documentation completely rewritten from scratch, containing anything and everything you might want to know about the protocol, as well as guides to walk you through. Issuing subnames, easy peasy. Here's the URL to the guide. If this is something you want to build, we have a couple hackathon prizes open. I think we also have a hackathon bounty set for adding some better support to a couple open source libraries. So if you're not feeling like building something new and you want to work on an existing library, make a contribution to open source and get those lovely green squares on GitHub, and a sweet bounty, we're here for that as well, and we're happy to help. And that was it. Or not. Figma disagrees. That was not it. But this is the end of my talk. Thank you for being here, and I'll be at the ENS booth all weekend. So if you have any more questions, I'm happy to help.
How about L2s, like optimism-based? Like, how do you, because if you have to pay gas fees on Ethereum every time you want to update a record, it's going to be really costly.
Completely understandable. So here's the deal. ENS allows you to store your data anywhere. Leveraging EIP 3668, don't worry, it'll be in the docs, otherwise known as CCIP read, you can load any information from any chain. So if a user wants to, they could store their information on Optimism, Arbitrum, Polygon, you name it. We've built the EVM gateway, which you'll also find in the docs, which allows you to trustlessly load information from the aforementioned, which means that users can now migrate their data and store it on other chains. Now, obviously, this is still something we're heavily in development with, but at this point in time, anybody could build a system that allows them to give out subnames on Optimism, or give out subnames on Polygon, or give out subnames completely for free off-chain. And the way that works is you write a resolver, and then in your resolver function where you put that magic, you revert with off-chain lookup, where it should load the data from, or you use the EVM gateway right there, and then it will load the data, and it will work.
I just want to know, does the resolver, the contract that you write, does it work for testnets also?
Yep. We've got deployments on Haleski, Gurley, Sepolia, and I think all the other ones as well, but you know, testnets have a limited lifespan. But if you want to, I think we also have a couple of faucets that we're linking out to in the docs. So if you need some testnet tokens, you'll be able to test out on there. But yeah, all of the deployments are on there, and you can mess around with it, for sure.
Okay, and the last question.
You mentioned, yeah, very short. You mentioned Coinbase and Uniswap have a gasless experience for the building subnames.
Yep.
And is this to the point you touched on that you can create your own resolver on L2s? So that means they're hooking you up with the smart wallet accounts for 337. Is that how it works?
Yep, exactly. So here's the steps. Write a contract, deploy it to the L2 of your choice, and it's super simple. Most likely, if you're working with 4337, you'll have a factory contract that creates proxies, right? And then while you're doing your proxy creation, just make sure that in some storage slot in your contract, you store some funny name that the user prefers or that's still available, and the address of where their contract got deployed to. Should be super simple to do. Add some view functions to the contract that allow it to become a resolver and allow it to look up information from that aforementioned storage slot of your choosing, and then it will work. And then you'll write a contract on mainnet resolver that reverts to load from the L2, and then everything will work and hook up. Yeah. Sweet.
Awesome.
Thank you
Luc.
very much.
Thank you.